Hey guys, welcome back to another TryHackMe Capture the Flag challenge. Today we'll be working on something different, that is reversing the binary files. The room name is Reversing Elf, room for beginner, reverse engineering for CTF players. So there are total 8 binary files. We need to download all these files and then we need to work on it. I have completed it recently, and mainly I have used R2 or Radar 2. So we could use the ITA or um, the Ghidra tool, and basically we need to check the source. We might need to check the memory contents while executing the functions or steps in the source file. So uh, first first or maybe 1 2 3 files are easy, I believe. Crack me 1 2 and 3. For these we don't need to check the source. For crack me 4 5 and 6 we have to check the source in order to complete the lab. And for crack me 7 and 8, I have made changes in the instruction set using R2 tool. So I'm not sure if we could have cracked without making the changes, but let's get started from the very beginning, that is crack me 1. So, and before I start, I just want to mention that I have not created any tutorial video on using tool like Radar 2. So if I will create, I will mention it in the description of this video. So just have a look. If you find a link for R2 tutorial, so please go through from it. There I will explain some of the commands and steps that I'm taking. But for this lab I will quickly cover um, these labs to just to capture the flag and show the methods that I have used. Okay, so first thing first, all the files are there in this directory, and we have to set the uh, flag plus X basically to execute these binaries. Acme star ls minus la, and now we can execute these binaries. So the first one is quite simple: crack me 1 flag, not that kind of elf. So this is it for the first one. So I'll keep removing the files. Rm crack me 1, just to make sure that um, I don't get confused between these crack me files, which one I have to use to explain. Next one is crack me 2, so let's execute that one. Crack me 2, uh, basically it is asking for some kind of password. So let's try checking the not source but the strings which are there in this binary file. So we can use any text editor, or we can use the strings command. So strings crack me 2, and we can check all the ASCII strings here which are part of the source of this file. So if we scroll up, we can see access granted, access denied, and there is a string called super secret password. So we can test this super secret password string as a password, and it says access granted, and this is the flag. So let's move to the third one, crack me 3, and again it is also saying crack me 3 and use some password as argument. So admin, or maybe the same password, no, So let's use the same method and check all these strings. Here we can see correct password, and we can see there is a string. Most likely using this padding we can guess this could be base 64. So let's decode base 64 minus d, and this is the for second lesson, and base 64 all the things. So this is the flag, and we can test this as well, so why not. Crack me 3 and correct password. So remove crack me 3, clear, and we are left with 4, 5, 6, and 7 and 8. So from here onwards we will use R2 to decompile minus d, and we will check the source of these binaries. So crack me 4, and before doing that, um, let's run the crack me 4. So it says this time the string is hidden, and we used ctrcmp, so this could be kind of a function or something, and we can check these strings as well. So crack me, yes, seeing it anyways, yes. Oh, so I should not have used less commands, but strings, or maybe let's mention less here. So we cannot see any string which could be the password here, so it is hidden, it says, and definitely we don't find anything which we can use as a password or as a flag. So let's go to R2, crack me 4, and I will mention some password like AAA. So I've mentioned this string so that I can check what is my argument while decompiling this file, and what is the correct password in the code. So I will quickly run the commands. Check the tutorial video if you find the link in the description to understand the meaning of each command. So this is the main function, so just the basics if you want to know. So we just need to check the main function using pdf main. These are the variable, these are the memory addresses on the left, and the middle these are the opcode or operation code of the instruction mentioned here. So these are the instruction, these are the opcodes for each instruction and these are the arguments, you can say. So like move is moving the value from this source to this destination, and these are kind of jumps which usually happens when there is a if else or some loop commands are there. So jump happens after comparison usually, um, right? So in this case it happened after this function was called, and then the jump happened. Okay, so in this binary file we have checked there are two cases. One case is where we have not supplied any password, and it is saying that the usage is this and supply the password. So these instructions are related to the condition where we have not supplied the password, and if we have supplied the password, then this conditions, these instructions are getting executed. So in these instruction the steps are getting executed is one move command, then add instruction, then move, and there is a function called sim compare underscore pwd. So we can check the source of this function as well, instructions. So there are some variables in this function, and then some series of instruction. Then it is calling a function called get underscore pwd, and then here it is calling sim.imp.st rcmp. So we can check this one as well. So pdf at, and we can see that it is jumping to some value. So in R2 we can set some breakpoints. So I have copied this address, memory address, and I'm setting a breakpoint here, and then executing this binary. So the breakpoint uh, is, we are at now at this breakpoint. It says hit breakpoint at, and then we can check this function again, and we can see that we have reached to this step of these instruction. Now this will be called. So now we can check the values of these registers RAX, RDI, RSI, RDX. So let's check RAX and RDI. So we can see the memory addresses here, RAX and RDI. To check the value of RDI first, we can write at RDI, and there, this is the string, my more secure password. And if we check the RAX, I'm sorry, I have to check the RX and then RDX. So basically this move command is kind of copying the addresses to the register mentioned on the left. So RX, we have checked the RDI, and then we can check RDX or RSI, RDX or RSI. So RDX, and it says AAA, which we have used as the password while executing this R2D compiler. So this comparison is happening basically, and if this password is correct, then it will get accepted, um, and we will be able to run the instruction which is supposed to uh, run using this password. So Control Shift E to open a window here. So TryHackMe 3 4, okay, and the password is this WD, and it says password is okay. So this is it, and we can submit this password as flag. So quit, yes, and then rm TryHackMe 4 clear and clear. So on crack TryHackMe 5, enter input, then some input, and always dig deeper. So probably we need to enter some more text, and it still says always dig deeper, okay. And then, okay, I'm sorry, um let's see, good game. So some longer input is required in this TryHackMe 5. So let's see what is going on under in the source. So TryHackMe T, TryHackMe 5, AAA, and AFL, and PDF at main, and we can see many variables are created, and then some values are assigned to those variables here, and then some steps and 3 segments. One is good game, second is always dig deeper, and third is this one. So basically, uh, with these characters, with these variable, we can set some breakpoint, and once some word is created, then we can check register values and capture the word, exact word with all the letters. Otherwise, the reference is given here. So in hex, 0x4f means O, and ASCII letter is 79, 0x66 is F, and 102 ASCII number of F, and these are the letters. So what I tried is to note down this password 0fdl and use this as the input. And let's see, so I'm not writing it down again. So this was the flag which I submitted. So it is written in the exact same sequence, OFD, and in the last XTZ. So OFD XTZ, and we can use this as input to validate uh, if this is correct. Paste, good game. So this was the flag which was supposed to submit it on the TryHackMe challenge. Although the good game segment is getting executed when we are entering long value. So this thing is the same as the execution shown below, but the flag was needed to complete this challenge. Otherwise, we are able to execute this section anyways. So most likely there is no comparison happening between our input and the input which is set in this executable file. So that's it for TryHackMe 5. I'm removing it, and now what we can do is to check TryHackMe 6. So TryHackMe 6, and it says TryHackMe 6 and password. So this is the password at 123, and it says not okay. So let's check R2-D, TryHackMe 6, AAA, and AFL PDF at main, and basically two segments. One is this, second is this, according to these arrows. So one segment is this, where we have not supplied the password, and the other one is this. So here it is comparing the passwords. So in this segment, it is executing some instructions and then calling this compare password, and then nothing is happening afterwards. So let's see what if mention in this function. So again, two segments. One says password okay, other says password not okay. So we need to check a couple of things. So basically, this is executing another function which is secure SYM my secure test, and then it is testing and then jumping if not equal to this. If it is equal to, then it is jumping here and says password is okay. So let's see what is there in this function now. I believe okay. So this is a bit longer one. So I'm guessing this, since this is comparing the password, so and based on that it is jumping. So one argument is the our input which we are supplying, and the another string would be the output of this function, and then the comparison is happening. So the password is indeed in this function, and like in our previous challenge, we can see that some values are getting assigned or compared. Basically it is comparing one letter at a time, probably with our provided input, our letters, which we have provided, and the comparison is happening. Based on that, it is jumping, and these loops are getting executed from here, then it is coming above, then it is going down, then so this is kind of spiral loop for, since it is comparing each letter. So everywhere you can see the comparison is happening for one letter at a time. So so our input is getting compared with another letters. So what are those letters? Those letters are 49, 51, 51, and this minus 1 we can ignore because it is same everywhere. So let's write it down. So from starting, first one is 49, then 51, then 51, then 55, 95, 55, 95, 112, and 119, and 100. Okay, so these, since in our previous video we have checked that these were the ASCII letters, so we can search for ASCII table, uh, and we can check the exact character from these decimal numbers, ASCII decimal numbers. So 49 is 1, 51 is 3, and again 51, 3, 55 is 7, 1337 looks familiar. Then 95, so 95 is underscore, and 95 is underscore, then 112 small p, then 119 small w, and 100 is d. So 1337 underscore pwd. Let's validate this. So we are on TryHackMe 5. For TryHackMe 6 we are on TryHackMe 6, right? Yes. Okay, so TryHackMe 6, sometimes it is very confusing because the names are very similar. So we need to supply the password, 1337 underscore pwd, password. Okay, so this was the password, but are we supposed to get some kind of flag, or was this was it? What was the password? So password is this. Yeah, so there is no further flag in this um, challenge, so we can quickly move to the next one. Next one is TryHackMe 7, and in this challenge we need to make some modifications according to the method which I attempted. So it says three options are there, or probably let's select the third option and exit from here, and I'm using this window to execute TryHackMe 6, no 7. And first is say hello, your name, my name is Google, hello Google. Then again the menu, then I'm selecting second option, add numbers, enter first number, enter second number, and 1 plus equal to 2, and then option 3 is quit. But if I select 4, unknown choice, and if I select 3, it says goodbye. Okay, so I'm uh, keeping this window open right here, and let's decompile the seventh challenge, and let's see the how the source code looks like. So from the very beginning we can see a couple of variables are there, and then there is one argument, and I will quickly go through it. So this is option 1. Option 2 will be there somewhere below, and every time it is coming on the top, not every time but on two conditions. When we have selected 1 or when we have selected 2, it is coming back to the menu. Like here we selected 2 and it came back to this menu. So and it is starting from the beginning. So if we have selected the option 1, what it is giving, if we have not provided correct input, it is saying wrong input, and this is the option 1 exactly. So what is your name? Then it is trying to read, and if it is not able to read, then it is showing unable to read name. If it is able to read, then it is printing hello. Then the second option is enter your number and first number, and then the same thing, unable to read, and then second number and unable to read, and then here it is adding those numbers. Here you can see the addition is happening, and here the it is printing the final value. So like 1 plus 1 is equal to 2, and uh, here the option here is the option 3. It says goodbye, and the if we have entered 4, so it is saying unknown choice, and there is one segment which is not getting executed anywhere. So and we can see that in this segment there is a function called give flag. So we can check the content of this function, but most likely as per the naming convention this function is supposed to give flag back to us. So we have to find a way to execute uh, the set of instruction. So what we can do, um, we we can provide uh, 4 types of input roughly, 1 to 3, and the fourth one is any random number where it will say unknown choice. And if we will select 4, it will execute this segment. If we will select option 3, it is executing this segment goodbye, and just after this segment we have our hidden uh, segment or instruction. So what I want to do, I want to um, mm, remove this jump, or maybe bypass this jump instruction. So if I select option 3, what I want to do, when I want this executable to execute the instruction, that this jump should happen here. So from here to here instead of this. So this, what it will do, it will skip this part. Okay, so to do that we need to change the instruction, and uh, I believe WA is the right syntax. Let me check my notes quickly. This is not that common. Yep, WA, and then we need to write the instruction. So instruction is JNE. I'm writing the same instruction, JNE, and I want uh, this jump to happen to this memory address and not this one. So, and where I want to write this instruction, I want to write this instruction here. So this will overwrite the instruction. This instruction will get overwritten. And one more thing before I execute, there is one more change required. So what is happening? This is saying jump if it is not equal to. So if we will enter any input, if that input will not be equal to 3, if our input will not be equal to 3, then this jump is happening. However, this segment is getting executed when our input and jump is 3. So I want to change this not equal to jump equal to. So JE instead of JNE. So I'm explaining it again. So if the this jump will get executed, this jump will get executed when our input will be 3 and it the comparison result will be true. So is our input is 3? Yes. And if yes, then this jump will get executed. So I have updated the memory address and I have changed the instruction as well. So let's compare it, if the changes is correctly written or not. So I'm taking a screenshot. So starting from here, roughly till here, and if I check the main function again, and now we can see that this thing is written here, and now this this jump is happening here, I mean here, and not here. So this arrow has moved to here. So whenever we will execute 3, it will basically it will execute our segment which we are supposed to run and capture the flag. So I hope I tried my best to explain this, but it is little tricky. Sometimes I get confused as well. So anyways, let's run. So DC, it is asking for some option. I'm supplying 3 as the input. So it has executed wow such hacker or H4 XOR, and the flag is this. So I hope you understood the point. So this modification was done for TryHackMe 7, and similar thing will be done for TryHackMe 8. So last one, TryHackMe 8 usage is TryHackMe 8 password. So this is the password. Access denied. There is no other case, only 2 cases. One case, password not supplied. Second case, password supplied but access denied. And third case could be the correct password. So decompile TryHackMe 8. What I'm doing, AFL PDF at main, and roughly 3 or 4 sections we can see. So this is the section where we have not supplied the password. Then this is some section, and this is some calculation is happening here, and then based on that, this is the one section. So where here we have not supplied the password. If we have supplied the password, some calculation will happen, and then either this segment will get executed, which is access denied, or this segment will get executed, which is access granted. So we can make changes at multiple level. We can change the jump instruction. uh, this one we can update this instruction to probably this one. So if we will not supply the password, it will execute this and it will give us the flag. Or we can do one thing, that we can change the jump instruction of this one maybe. So what is happening here, if we have supplied the password, it will compare if the password is correct. If something is equal to, then it is executing this. If it is not equal to, then it is executing this access denied segment. So we know we can execute this part by supplying the wrong password, and this section will get executed. But once this section is getting executed, what is happening, it is coming to this instruction and then uh, moving jumping to this one, and we are leaving this instruction set. So I want to change this jump from here to here. So basically I'm not removing any instruction, I'm just saying that jump to this one, the very next one. So uh, there could be methods to delete the instruction completely, but I'm not sure if that will mess up with the memory address or some kind of sequences. So I'm just updating this address which is written here. So the same thing which we did in the previous video. So in that video we have changed the JNE to JE. Now we are changing the jump instruction, and instead of this I want to write this one, the very next one, and we want to update this instruction at this memory address. So what it will do, it will execute this segment, it will say access denied, then it will move to this instruction, and this jump will move to next instruction, and it will say access granted, and it will give us the flag. So let's check the function again. So we have changed the arrow, and it will first say access denied, then it will say granted, and then it will give us the flag. So DC crack me. Okay, so it moved to the last part. Why? Because we have not supplied the password, and this usage segment, this got executed, and because of this instruction this moved to the last part. So we have to execute again with the argument password. I'm not sure if we could use OOB command to supply the argument uh, when we are in decompiling mode in R2. Anyways, so let's do this whole thing again, um, and we executed this jump. So I'm just matching the addresses here. Yes, so it looks correct. So we want to update instruction at 500, and it should be mapped to 502. And if we check it again, indeed the changes looks good, and we can run. So it says as expected access denied, access granted, and here is the flag. So flag says at least this cafe won't leak your credit card number. So there could be other methods to crack this. We could have analyzed the functions, all functions like this one, this one, this one, and this one. But since we can see the give flag function is there, so it is supposed to give us the flag back. So this was the easy method. I'm not sure if other methods are there and it will work. And this is it for binary exploitation or reverse engineering, whatever you call. So I hope you have enjoyed and learned something new. If I will be able to create the tutorial video on R2 where I will explain the commands and some instructions in little bit of detail, whatever I can. So I will create the video and I will leave the link in the description of this video, so you can, if you will be able to find the link, you can watch the tutorial video. Until then, have a great day. Bye bye.